Hello again. This is part 2 of homework help for the exponents review worksheet. So I'm going to do a few more that are toward the end of the worksheet on the back. Number 16, we have this crazy mess. So we know we can multiply all these in any grouping we want on the top part of this fraction. So I'm going to just rearrange it so I can see it better. So 3 times 4 times x squared times y over negative 6xy to the squared. Now don't get fooled by this particular negative sign, because this just means negative 6. It does not mean the same thing as a negative exponent does. It does not mean it needs to go to the other side of the line. Okay, simplifying this across the top, 3 times 4 is 12. X to the 1 times x to the 2 is x to the 3. Y to the 1 times y to the 1 is y to the 2. I'm just counting my variables. And then it's negative 6xy to the 2 in the bottom. I'm going to take that over here and simplify it more. So 12 over negative 6, I'm just going to rewrite it. Whoops, y2, xy2. Okay, so this is like 3 x's and this is 1. So 3 minus 1 is 2. And that cancels out. So this becomes a 2. Y2 over y2 cancels to 1s, so that's not going to be there. And then 12 over negative 6 is just a negative 2. And that's going to be all over 1, which is going to equal just simply negative 2x squared. Okay? So we have some scientific notation next, which is pretty fun. Remember, it's just like a storage system for zeros, so you can express big numbers with just a few zeros. So the decimal point right now is here, but I want to put it in scientific notation. So where it needs to be is in that range, because we can only have a ones place number ahead of our decimal. So we're going to move the 0 over 1, 2, 3, 4 spaces. So it's like 10 to the 4, because this 10 to the 4 has 4 zeros. And we're going to say 7.8 times 10 to the 4 is our scientific notation. Now, why didn't I do 78 times 10 to the 3 or 0.78? Just because that's not the standard that's accepted. We always put scientific notation in a ones place digit right here, followed by a decimal, and then any extra information in terms of more numbers go right behind it, and then you tell which how many numbers you're talking about. The positive numbers means it's a number that gets larger, right? So if it's 10 to the 100, that's a huge number. A negative number does not, a negative exponent here does not mean a negative number. It just means a number like this that is smaller than 1. Okay, so we're going to find out what this number is in scientific notation. So in order to take it to scientific notation, I'm going backward 1, 2, 3 spaces, and there I have my form where those are ones place and there's 2 additional numbers. So 4.31 times 10 to the, I went backward 1, 2, 3 to the negative 3. Okay, that means that in order to get this number back to its standard form, you have to scoot back 3 tens places. Okay, This one is in scientific notation, and they say, well, what is this number in standard form? So the negative exponent here tells me that it's going to be something like this, that it's going to be less than the number 1. It's not a negative number, but it's less than the number 1. Incidentally, if I had a negative number, you'd see a negative sign show up right there. Okay, so this one is pretty easy to do. I'm just going to expand the number based on my instructions here. So I'm going in the negative 5 direction, so I'm going to go that way. So it's 1, 2, 3, 4, 5 is where my decimal is going to be. 4, there we go. So it's 0.0000, that's 4 zeros, 98. Okay, this one I have started because I was afraid we would start running out of time, and I'm getting kind of like a long video here. You always know you can listen to these videos on double speed or 1.5 times speed if you need to just hear it quickly, but you don't need too much processing time. So this is doing an operation with scientific notation. So you can see I have a number in scientific notation here. It's a big number because it's 10 to the 7, so that's like in the 10 million range. And I have a number here that it's just 30. It's 3 times 10 to the 1, but that's how you express it. You don't go past a ones place number. Okay, and I can just use the commutative property of multiplication to regroup these numbers. So I took these out of their parentheses, and then I went ahead and regrouped them. So I'm going to put the numbers here, and I'm going to put the tens business over here. And then you probably can tell what I'm about to do is I'm going to say 6 times 3, oh, that's 18, times, because we always leave scientific notation in multiplication form, times what? Well, times 10 to the 8th, because we have 7 tens here and we have 1 10 here. So added those together, you have 10 to the 8th. So you kind of need that skill of adding exponents to be able to do an operation in scientific notation. Okay, and then number 22 has you dividing in scientific notation. And there's a few strategies you can use. I'm just going to show you one. I rewrote it with the tens up on the same line, and notice that I made this 10 a -3 when I moved it up from the bottom line to the top line, because I took the inverse operation of 10 to the 3rd power. I did this so I can, it's just easier for me to add exponents. So I'm going to divide these numbers, so 9.6 divided by 1.2, just a division problem, 0.6, and then I'm going to do this, my calculator so I don't have to make you guys wait, and so I don't make a mistake. 9.6 divided by 1.2 is 8. Okay, so this is going to equal 8 times 10 to the -5, because I have a -2 here, and then I'm adding another -3 here, so that gives me a -5. That's a really small number. And that makes sense because I start with a small number. 0.096 is the number I start with, which is like 9/100ths. And then I divide it even further by a pretty decent sized number. So that makes sense that I have a very small number. Okay, so hope that helps. Please email me if you have any questions tonight, and we'll go over this in class tomorrow.